Hello friends, it's Susanne, and today I want to show you how completing the square works. We go through these two examples together. In both examples, we will work with a quadratic function. We have a part with x squared, a part with x, and a part where there is just a number. But in the first example, there is no number in front of my x squared to see, and that's the difference to the second example where we will have a number in front of our x squared. Let's start with the first example first. Completing the square is a technique that helps us to convert a quadratic function from the standard form as it is right now to convert this into the vertex form. So completing the square will be used during this process. When and where? Not at the beginning initially, so the very first part is that we take a look at our x squared and check whether there is a number in front of my x squared or not. If there is no number, it's the easier case, then we don't have to look at this anymore and we can go to the next step. The next step then is to separate these parts here. We are first interested in the part with the x squared and the part with the x. So these two parts are interesting for us. This part where there is only this number is not interesting for us. We won't use it, but we have to write it down, of course. So the plus 38, we will write it down at the end with a little bit more space because we will need it. But this last number, you can just write it down at the end. We will use it only at the very end of this technique. Okay, so we are interested in the first part, in the part with the x squared and the part with the x. Now, there is so much space here. This is where the completing the square technique is applied. We will add something now and subtract exactly that again. So in general, we are not allowed to change, just to change something in our function. But if we add a number and subtract the exact same number immediately again, then we didn't really change something, right? So for example, this is not what's going to happen, but for example, if you add the number 8 here and you subtract the number 8 again, then you haven't really changed anything because 8 minus 8 equals 0. So you don't have to write this down, but maybe it will help you. And this is what completing the square is. It helps us by adding something so that we get a new structure. But what do we have to add here and subtract then again? We go to the part with our x, not the x squared part, but the x part, and take a look at the number that is in front of our x. The 14 in our case. In your case, it could look different, but you take this number and you divide it by 2. So always divide this number by 2. It's a 14, so if I divide it by 2, I get a result of 7. I write down the 7 here, but that's not everything. We have to square this number as well. So you take your result and then you square it. That's all you have to do. And then don't forget to subtract that again because we're not allowed to just change anything. So we subtract exactly that again. So you take this, the 7, and square it and subtract it. This part, what we just did, is the completing the square part. But why have we done this? We need the first 3 parts of this now. So the part with the x squared, the part with the x, and this number that we added. And we are going to factorize this sum here now. You always do this. So this sum can always be written as parentheses that are going to be squared. Then you have either a plus in here or a minus, depending on the symbol here in front of your x part. If you have a plus here, you will have a plus in here. If you have a minus in here, you will have a minus in here. But we have a plus, so we have a plus here. But what do we have to write down here now in front of the plus and after the plus? These are always the parts that are squared here. So we have the x that is squared here at the beginning, and we have the 7 that is squared here at the end. You take the x and put it in front of your plus, not the squared, but the x. And after the plus, we have the 7 here. Not the squared, just the 7. So your thing, however your numbers look, you can always write it in these parentheses in this way. And the rest of this, what we have here after all of this part in front of this, we just calculate it. So we have the minus 7 squared equals 49, and we add the 38 at the end. And we are almost done. We have these parentheses, which are great. You just leave it like this. They are in the perfect form that we want. And these numbers are just added now. So we have negative 49 plus 38 equals negative 11. And this is the vertex form we were looking for. So we used the completing the square technique to convert our standard form into this vertex form. And we completed the square here. We subtracted this part again, but we needed the specific square here so that we could write these 3 parts here into this form that we needed for the vertex form. And in the second example, this is going to be a little bit more difficult because this time we have a number in front of our x squared. This changes things, but in general, it's very similar to what we just did right now. First of all, we take a look at our parts. We have a part with x squared again, a part with x, and a number. And we are still not interested in this number. So we take the 82 and write it at the end. We will just need it at the very end of everything. So we are not interested in this, but it is part of the function, of course. So don't forget to write it down. But here, the first 2 parts, that is what we will work with. So we write them down again. But now we are not allowed to start with completing the square technique right now because we have a number in front of our x squared. So be aware of that if you have a number here, do not add and subtract the squares right now, but we have to factor out this number first out of these 2 parts. Not out of this last part, so the 82, you can write it down again, but we factor out the 3 out of this sum here. So if we take out the 3, what is left in my parentheses then? I have the plus here in between, so I can write down the plus already. Here in the first part, if I factor out the 3, only my x squared is left. And if I factor out the 3 here, 18 over 3 equals 6, and then don't forget the x. Okay, why did we do that? Well, we said that we don't want to have anything in front of our x squared, and we managed to do that. So now we're going to apply the completing the square method inside the parentheses. So here we can write down the parentheses a little further away because now we're going to complete the square. So we're going to add something and subtract it immediately. What is it that we're going to add? Well, we said we go to the part with the x and take a look at the number in front of the x. This is a 6. We always divide this number by 2. So 6 over 2 equals 3. And then don't forget to square this result, so we square it. And then we subtract this thing here. So we take the 3 squared and subtract it immediately. Because now we did all of that because we want to factorize these 3 parts here. Everything else, we write it down as it is. We don't change anything. So we have the 3 here in front of our parentheses. We have the plus 82 behind the parentheses. And inside the parentheses, we factorize this part here. So you can always write this as parentheses squared. Then you take a look at the thing in front of your x. It is a plus, so you can write down a plus. If it's a minus, you write down a minus, but it is a plus. And then what is in front of my plus? Well, I go to the square part here and the square part here, and I take only the x and write it in front of my plus, and I only take the 3, not the squared, only the 3, write it behind my plus. And then don't forget to subtract this part. We didn't use it for this factorizing part, so subtract 3 squared, and 3 squared equals 9. This was the completing the square technique, but we are not finished yet because this is not yet the vertex form. So now, if you want to use the completing the square method to find the vertex form of your function, we have to do some more steps because this doesn't look perfect yet, because we have here these parentheses still that are multiplied by the 3. So let's get rid of these parentheses first by multiplying the 3 by each element in here. So we multiply the 3 by these parentheses, and we multiply the 3 by this number here. So we have y equals 3 times this first part. We write it down like this. So 3 times these squared parentheses, and then we have this minus, and we have to do 3 times the 9, which equals 27 now. And don't forget the 82. And now we are allowed to add these numbers here in the last step. Everything else in front looks good for the vertex form. We have a number in front of these parentheses that are squared. And here, negative 27 plus 82 equals plus 55. And this is the vertex form. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!